Today we're going to continue with equations. Okay, now what do we do when those equations have even more pieces involved? Okay, so not just one step, not just two steps, but what happens when we have a lot of steps going on? Okay, how can we get those simplified, combined, and do something with them? Okay, now let's also be realistic. My students are like, why am I doing this? This is pointless. There's never going to be a job. Even teachers, well, you do it as a teacher. Okay, yes, I teach how to solve equations. Okay, but you're not going to get a job that all you do all day is solve equations, because I also do other things. Right? The reason why we are learning equations is for the bigger picture. Where do we use equations? When in the past have you actually been able to use an equation that relates to something real world? Lucy? Story problems when you're like at the store and we want to find out how much something costs. Okay, I wanted to paint my daughter's wall and I need to figure out what size squares to put on there because we did a unique design. Okay, so yes, we are looking at multi-step equations today, but not as an individual topic. Our long-term goal is that we can use them real world in real life situations when there are story problems that relate to things. Okay, so I am going to give you some information today. I always struggle saying this because I don't want you to, I'm not writing the Bible today is the deal. I'm going to give you some rules. I'm going to give you some steps. I have realized my students are getting old. They're kind of guidelines, you know, like Pirates of the Caribbean, like they're guidelines. Okay, they're not written in stone. It doesn't mean there aren't other options. Okay, but when we're looking at an equation that has a lot of pieces to it, sometimes it helps if we have a process we can walk through to break it down. So that being said, the first step we're going to look at with equations that are, I would call them long. Some of the equations we look at will be long. They will have a lot of pieces involved in them. The first step that we will do is if we see parentheses. So if there are parentheses, we are going to distribute. Okay, so remember those properties from, past school years, the commutative property, the associative property, the distributive property. Remember those? What does the distributive property tell us to do? And what does distribute mean? But in English, to pass out, right? If I distribute papers, I'm passing them out. Okay, so I'm going to pass out the number that is sitting in front of the parentheses. And when I pass it out, what operation am I passing it out with? Multiplication. Okay, so I'm going to pass it out here, and I'm going to pass it out here. If there are 10 things inside of the parentheses, I pass it out to all 10 things. Okay, and 4 times x gives me what? 4x. And 4 times 3 gives me
12.
And usually my students say, okay, no problem. That feels fine. We need to make sure that we don't get so excited about the distributive property that we don't get our signs correct in the process. So if we are given 4 minus 5 minus 2x in parentheses, does this problem have parentheses? Yes. So do we need to distribute?
Mm-hmm.
Yes. What do we need to distribute?
We need to distribute
Negative sign.
We need to distribute. Same rules as before, right? What's directly in front of it?
So
This 4 is too far away. And what number is sitting next to this negative sign?
1.
DJ?
So like when there's no number next to x, you just put a 1 there?
Ah, right here? Is this what you're saying?
Yeah, so then you
Yes.
just put a 1 right there.
So same thing here. Yep. Yep. Okay, so we're going to distribute negative 1. And I start getting these glorious questions. I swear if I got paid a dime for every time I was asked this, I would be rich. Well, is that a negative or is that subtraction? And what does Mrs. McKinney say? Yes, it's both. Okay? However, when I say yes, it's both, I don't mean you can pick both at the same time. You have to pick one and you have to stick to it. I think the easier one to choose is to choose it to be the sign of the number. So when we distribute, -1 times +5 is -5. So I'm going to write down a -5. I would then not treat this as subtraction. I think it's always easier to assign it the value to the number. That is me personally. I am not saying that it is wrong if you don't. You will then have to deal with cleaning up two signs, and if you are fine with doing that, fine. Okay, but if we say -1 times -2, what is -1 times -2x? Positive 2x. So we'll just write down positive 2x. And that fills in the operation that I need. And then anything that you haven't used just falls straight down. So this 4 just comes straight down, and I end up with something that says 4 minus 5 plus 2x. Questions on distributing that negative there? Say we're okay with that. Uh-oh. Oh, I didn't even see kids before I was passing it up. Second step says, if, hang on, let me fix this in attendance. If there are like terms, combine them. So we talked about this on the very first day of the trimester. What are like terms? Not the same sign. That wording there isn't quite the wording we want. I'm guessing if I wrote it down, you'd all be like, oh yeah, those are like terms. But what does it mean if we want to explain it? William?
Like, if there's like 5x and then plus 6x, you combine them to make 11x.
Why can I combine those? You're exactly right, but why?
Because they're the same. They mean the same thing, I guess.
They have the same variable.
Yeah.
Right? They have that same label. They have that same variable with it. Okay, so when we're talking about like terms, everything about that variable that is with it needs to be the same. So if we have something like we just left off with over here, right? 4 minus 5 plus 2x. Are there like terms I can combine here?
Yes.
Yes. Okay, but we just said it was like variables, but I don't see that variable more than one time. So what are my like terms here?
4 and 5.
Right, the regular numbers. No variable means they have the same variable, right? This one has no x's, and this one has no x's, so these can go together. Right, so 4 minus 5 is -1 plus 2x. Now, that could be something much more complicated. Right? The reason why we like to do this step is because it gets everything simplified, especially when we have a long problem. It can look super overwhelming until we combine like terms. So what like terms do we have up here?
6.
6, 8.
And what does that become? -5, are we agreeing? Do we want to write that -5 first, or do we want to write that -5 second?
Second.
What do you think?
Doesn't matter.
It doesn't matter is a true statement. What do we usually prefer? Let's see. Let's keep going. Not sure we have an opinion on that yet, which is okay. What else can we combine? 5x, x, and negative 4x. And what's that going to become? 2x. Do we want to put a positive 2x here or a 2x here?
2x.
There's where I'm seeing more of the preference. Now, 2x minus 5 versus a negative 5 plus 2x, mathematically speaking, is the exact same thing. It doesn't matter. Okay, but it's also in something that we call standard form. We'll get to that more when we get to polynomials. A lot of my students prefer this 2x in front, followed by the constant. It's not a right or wrong. Okay, just something I tend to see as a pretty consistent way of writing. Okay, so here's what we're going to do next. Step 3. Put right here as step 3, and then count the same amount of rows that you just used for the last one. So for step 2, if you use like 5 rows, count 5 rows and leave them blank. So that we don't have to rewrite notes down tomorrow. It's going to make tomorrow way easier note-wise. Does that make sense? So like, yeah, leave a few lines, skip step 3, and go to step 4. Step 3 opens a whole other can of worms that we need to spend more time on, so we're just ignoring it today. If there is a large fraction, I'm putting large in parentheses. I made that up in quotes because I made that word up. I don't know what else to call it. Right? It's that type of concept we were talking about in the POD. This has multiple things in the numerator. This does not. We have to treat them differently because this really truly has parentheses. Okay, so if there is a large fraction, we need to first isolate it. There's a big word. What does the word isolate mean? Get it by itself. And then we're going to multiply by the denominator, which is the idea we have been talking about. There's not really a whole lot of new information there. Okay, on that one. If we do all those things, we should be down to the things we've been talking about. Okay, those steps should leave us with a two-step equation or something simpler that will solve just like we've been looking at. Times 2x minus 4 minus 8 equals 28. Okay, so two choices. Option number 1, you solved equations a lot, you feel comfortable with it, you just start solving because there's this piece that just tells you know what to do. Right? You've done it enough, you just recognize it. Option 2, I'm not so comfortable with an equation. maybe there's a lot of stuff going on. I need to break it down step by step. So I'm going to read step 1. If there are parentheses, does this problem have parentheses? Yes, so if there are parentheses, what are we going to do?
Multiply.
Distribute. So we're going to multiply. So we're going to pass out this 3.
6x.
So 3 times 2x gives us a 6x. Three times negative 4 gives us a negative 12. Everything else is falling straight down. So I'm bringing down the minus 8 equals 28. For those of you who say, well, I don't need to write that down, yes, you do. Why? Because Mrs. McKinney says so. Okay, this is one I don't budge a whole lot on. There will be times that it is appropriate and we might be able to shorten this up, but right now, we need to be showing work and making sure we're understanding and able to explain those steps and concepts. Okay, step 2 says if there are like terms. Do we have any like terms?
Yeah.
Yes. Combine them. What like terms do we have? Negative 12 and negative 8. What is that going to give us? So 6x minus 20 equals 28. Are we okay on that one? So far so good. Step 3, we're avoiding. Don't have anything. Step 4, if there is a large fraction. Do we have a large fraction?
No.
Nope, so we're going to skip it. Step 5 says undo any addition or subtraction. So do we have any addition or subtraction? Yep, so we're going to undo that. Oh, what am I doing? See, so 6x equals 48. And then we will undo any multiplication or division. And we get 8. How could we check and see if we're correct? Right? Substitute it back in and type this in like it was an order of operations problem. Right? So you type into your calculator 3, open parenthesis, 2 times 8 minus 4, close parenthesis, minus 8 equals, and your calculator better spit out 28. Okay, so here's where we're at. I can stand up here and I can